Okay, we want to begin our first class on organic chemistry. Organic chemistry. All right, so when we talk about organic chemistry, what is the major element that is involved in organic chemistry? Carbon. Carbon is the major element that's involved in organic chemistry. Carbon is the major element. In organic chemistry, we deal with hydrogen and carbon, and then because of the ability of carbon to catenate, that is why it is a major element. When we mean, what do we mean by catenate? Catenate means the ability to form straight chain or branched chain. Carbon has the ability to form straight chain or branched chain. That's the meaning of the word catenate. So I'll give you three reasons why we use carbon majorly as a major element. One, it has the ability to catenate. Two, it can easily combine with hydrogen. Two, it can easily combine with hydrogen, nitrogen, and halogens. So it can easily combine with hydrogen, nitrogen, and halogens. Three, carbon has the ability to form single bond, double bond, and triple bond. So these are three reasons I can give you why we actually use carbon as the major element in organic chemistry. One, it is that it has the ability to catenate, that's to form straight or branch chain. Two, it has the ability to easily combine with hydrogen, nitrogen, and halogens. Three, it can easily form single bond, double bond, and triple bond. There are some basic terminologies. By the way, when we talk about single bond, it's a single line, double bond, double line, triple bond, three lines. There are some basic terminologies that we use in organic chemistry. But first of all, we're going to start with understanding the prefix in organic chemistry. So what do we mean by the prefix? It means the number of carbon. Number of carbon. When I have 5 carbon, what should I write as the implication of 5 carbon? So the prefix they start with met. Met is for 1 carbon. Et. Et is for 2 carbon. Then we have for the third carbon. So we have them in that order. And then we have hept are 7, oct 8, non is 9, dec is 10, on deck is 11, and duodec is 12. So this is the prefix we have when dealing with several number of carbon. We If I have 3 carbons, it has to come with the name prop. If I have 4 carbons, it has to come with the name boots. Let's go to the next now. So we want to see these basic terminologies there. We have the homologous series. Homologous series is a family of organic compounds that follows a regular structural pattern in which successive members differ from the previous. So the next member is going to be different from the other one by an addition of a carbon and 2 hydrogen. That is what it means, the addition of a carbon and 2 hydrogen, CH2 group. So alkenes differ from alkenes by that. And then there's hydrogen is going to be added or removed, it depends on the situation, but 2 hydrogen will be the differences. Alkyl group, rather, in this case, is going to be different from every other homologous series. Why? Just by the loss of an hydrogen atom. So for alkyl group, there's going to be a loss of hydrogen atom, such that if methane is CH4, it's going to lose one hydrogen, CH3. 3. So if I have an element C3H8 propane, it's going to lose its an hydrogen, so C3H7 propyl. That's how it's going to be for alkyl group. Whereas the functional group is an atom or radical. Radical is a group of atom. Radical is a group of atom. Okay, like NH2 is a radical. An atom or group of atom or a bond common between homologous series. So when we have several bonds that are common between homologous series, then that will give us what? A radical. So now we want to do some introduction. There are some basic rules though, but I'm going to introduce to you 3 of these homologous series, and then you see their difference and how then to work with them. The first I want to introduce to you is called alkanes. Alkanes. Then we also have alkenes. See, the difference is ANE, ENE, and then we have alkyne, YNE. So for the alkane, give an example: hydrogen, notice that they are all single lines. That means single bond. Like I told you before, now this single line means single bond. Then for alkene, you have, you see, I've introduced a double line. That means double bond. Please, this double line only exists between carbon and carbon. It is not between the hydrogen. So in this case, it's going to be a loss of 2 hydrogen. And also you must understand, carbon must form with 4, 4 for it to be complete. Carbon has to form with 4 for it to be complete. Remember your carbon: hydrogen, helium, lithium, beryllium, boron, carbon. Carbon is atomic number 6. So if you draw your structure, you notice that it needs 4 for it to be stable. It needs 4 electrons for it to be stable. So carbon must always form with 4 of the lines. So if you check it carefully, carbon here is with 1, 2, 3, 4. Whereas the carbon here is 1, 2, and these 2 line 3, 4. So that's complete. That's why there's no more hydrogen here. By the time you put an hydrogen here, it's not it's, go, it's going to be wrong, because it's going to be carbon with 1, 2, 3, 4, 5, which is very, very wrong. We come here now to the alkyne. You see that it's going to be having triple bond. That's how it's going to be. That's how it's going to be. Why? See your carbon here, 1 and 2, 3, 4. And this other carbon, 1, 2, 3, then 4. That's how it is balanced. So how do you name this now? Just with the way it is: 2 carbon C2. How many hydrogen? H6. Here we have 2 carbon C2. How many hydrogen? H4. Here we have 2 carbon C2. How many hydrogen? H2. See, if you notice their difference, what is the difference between this series? 2 hydrogen is short from this. 2 hydrogen is short from this. So that's why the homologous series there, so that they differ by 2 hydrogen in the homologous series. Well, we'll start with these 3 um, elements, these 3 functional group homologous series. Now I'm going to give you a basic rule that should help you to name several of these. As we progress, we are going to understand the halogens and how we work with them. But then, apart from that, we also have the alkyl. Alkyl. Alkyl, just as we have alkane, we have um, CH4, which is hydrogen with 1 carbon, 4 hydrogen with 1 carbon. The alkyl is going to be CH3. So whereas this is methane, because it's in the alkane family, this is going to be methyl or methyl, short of 1. So if I go further to have C2H6 here, which is 10, see it met one carbon, et two carbon. So for this case, if I have C2H5, it's going to be ethyl. Ethyl. Well, there are some basic rules in naming. I'm not going to give you the comprehensive rule now. I'll give you the basic one to start with so that you can do some examples, and then later on we'll go into comprehensive ones. The first rule is what? Identify the longest possible carbon chain. Longest possible carbon chain. That's what you are going to identify. So when you identify it, you give it its prefix, because this longest possible carbon chain will determine the prefix it's going to have. Then number two, after identifying it, you check the functional group. Check the functional group. If it is single bond, it's going to be alkane, so ANE is going to be addition. If it is double, it's going to be alkene, ENE. If it is triple, it's going to be alkyne, YNE. So take these two rules as we begin. If there are, the next stop is if there is a substituent. If there is a substituent, what do? You give it a number. You give that subsequent a number. For instance, if I have CH3 there and it's at the third carbon, I'm going to give it 3-methyl because it's at the third carbon. So just note these rules down as we progress to deal with other issues. Alright, so let's try these several examples here. So we have Alright, so let's try these several examples here. We have number one, the C there, then hydrogen. So the rule we said is what? We are going to check the carbon chain, then the bond or functional group, and then you also go on to check if there is what? Substituents. That's it. So how many carbon do I have? 2. That's all. So 2 from our table is what? Earth. That's it. The prefix 2 means earth. And then you check the bond. They are all single. Since they are all single, is alkane. So you attach ANE. That's how you deal with that. Very, very simple and clear. Next, 3 carbon. 3 carbon. What do? Prop. That's the carbon name. That's the prefix prop. They are not all single bond. There's a double bond here. So I'm going to number. Let's say I number from my left 1, 2, 3. The carbon is going to be between carbon. The double bond is between 1 and 2. The lowest is 1. So remember I said least possible carbon chain. If I number from my right, it will be 1, 2, 3. The double bond is going to be between 2 and 3. Lowest is 2. And since between 2 and 1 is lowest, I'm not going to take the numbering from my right. I'll take the numbering from my left so that it is at the 1 end. So considering that, it's going to give me propene double bond in, or prop 1 in, because it's at the first carbon. Prop 1 in. Go to the next. How many carbon do we have? 5. So that gives you your prefix name, pent. Then are they all single bond? Yes, they are all single bond, so no stress. It's alkane, pentane. Go on. Number four, carbon, how many are they? Four. The prefix table is what? But. Then when you check the whole arrangement, they're all single bond. So it should be what? Butane. But then there is a substituent here. Its subsequent substituent is what? Methyl. Now we're going to find the number or the position of the methyl. If I count from my left hand side, it will be 1, 2, 3, 4. So the carbon is going to be at, the methyl is going to be at carbon 2. If I count from my right hand side, it will be 1, 2, 3, 4. Methyl will be at carbon 3. So which of them are you going to take? Take the least. Take the least. So I'm not going to use this. I'm going to use this numbering. So there's going to be 2 methyl. So my name now becomes 2 methyl butane. I think you're seeing how simple it is. So I'm going to give you a next question. You give a try.